Okay, so this is problem 1.5.131, and I already did this problem once, but my audio wasn't on, so I'm going to redo it, but it's already written out, so I'll just take you through what I've written. Okay, so the problem says, and you can't really read it here, but I'll read it to you. A gambler playing blackjack in a casino using 4 decks noticed that 20% of the cards that had been dealt were jacks, queens, kings, or aces. After X cards had been dealt, he knew that the likelihood the next card would the next card dealt would be a ace, king, queen, or jack was this right here. And then they want to know for what values of X is this likelihood greater than 90%. Okay, so because we're looking for this to be greater than 90%, then we're setting up this inequality here. And we need to first of all take this 90% and convert it into a decimal form. Okay, so that would be 0.90. And in order to solve these inequalities, we need to have 0 on one side because we're going to use the test point method. So what we're going to do here, what I did was subtract 0.90 from both sides. So that gives us this right here. And now we have 0 on the right hand side. And there's actually 2 parts to this problem, but I'll talk about that in a little bit. So here we are, and then we need to get a common denominator here. So what I did was I went ahead and multiplied the 0.90 times 208 minus x over 208 minus x. Okay. And at that point we have a common denominator, so we're going to bring these numerators together and go ahead and distribute the negative 0.90. Okay, so when we do that, this is what we're looking at. So we distribute the negative 0.90, you're going to get this negative 187.2 plus 0.90x, and that's over the common denominator. So now we would simplify in the numerator by collecting like terms. So you take the 64 minus the 187.2, and you're going to get negative 123.2, and then collecting the x's, you get 0.70x. Okay. All right, so at this point, that's how we've set this up for this first part of the problem. We have it set up now where we actually have one fraction and we have 0 on the other side. So we can now proceed to the test point method, which we need to find the zeros for both the numerator and the denominator. And when I say zeros, I mean we need to find the numbers that make the numerator and denominator 0. And those are going to be our partition numbers. Okay, so let's cover this up so it's not distracting. So we take the numerator, set it equal to 0 and solve, and you get x equals 176, and then take the denominator and solve, and you get x is equal to 208. Okay, we need to remember here that x actually can't equal 208 because that is a denominator and we're not equal to right here. Okay, all right. So the test point method then is for us to do a number line, and we're going to choose points, test points in each of these intervals. So our zeros were 176 and 208. In this interval I chose 0, this interval I chose 200, and this interval I choose 210. And what you're doing in these problems is you're actually, excuse me, when you go to plug these in, you're really just concerned with, do I get a negative or a positive? You don't really care what the number is so much. So for instance, and when you plug it in, you plug it into this. This is why this is boxed right here. You're plugging it into just this expression. Okay. All right. So when you plug in 0, you're going to get a negative number in the top and a positive number in the bottom, and a negative divided by positive is negative. This is for a little bit later. And then when we plug in 200, you end up getting a positive in the top and a positive in the bottom. So that results in a positive. Plug in 210 and you get a positive in the top and negative in the bottom, and that results in negative. So that's where I'm getting this chart to look like this. The chart starting out wouldn't have looked, it would have just been a plain chart with no signs on it, and then the test points would be circled, and I'm filling in these signs here as we go through and decide what the signs need to be. Okay, so negative, positive, and then negative. Okay, so based on this, because I'm looking for a positive sign here, greater than 0, the region that is the solution region is from 176 to 208. Okay. However, the way the question is worded, the way that they're asking us this question, they want to know what values of x is this likelihood greater than 90%. And then they ask the question, the number of cards dealt must be more than, and it has to be more than 176. And then they're also asking what it needs to be less than. 208 is not the number that it needs to be less than. 208 is the maximum number of cards in the deck. Okay. So 176 is going to be the left-hand point of what they're asking. To solve for the other portion of this problem, then, we have to realize that that we can't be more than 100%. So we need to actually take a look at where this inequality is also less than or equal to 100%. Okay. So when we do that, 100% as a decimal is 1. And we're going to do the same thing here that we did in the last part of the problem. So we're going to subtract the 1 and then get a common denominator. So multiplying the 1 top and bottom by 208 minus x. And then getting one numerator here and simplifying. Okay. All right. So this is what we're looking at. We're going to do the test, find the test, or excuse me, the partition numbers again. So we're solving each the numerator and the denominator. So we get 180 and 208. So 208 actually isn't, a valid solution here because, like I said, that's all of the cards in the deck. That's the maximum number of cards. So, but let's just go ahead and find the solution using it, and then we'll cross it out at the end. Okay, so if we do a test, a number line to do the test point method for this, I'm going to go ahead and circle in 180, and again, I'm using the same test points 0, 200, and 210, and again, the signs wouldn't be on here if I was just writing this out with you. You would be figuring out the signs. So when you plug in your test point of 0, you're going to get, and again, we're plugging it into this expression right here. Okay, so when we plug 0 in here, you end up getting a negative in the top and a positive in the bottom. And plug in 200, you're going to get a positive, and 210, you'll get a negative. So the solution, if we were just doing the solution and it wasn't a word problem that we were trying to solve, the positive region, the negative region here, because we're less than or equal to 0, would be these two intervals. But this interval doesn't make any sense. When you go out to infinity, we just don't have that many cards in the deck. So we're just going to cross that off. And the high end here would be 180. So the way they're asking you to fill this in, the number of cards dealt must be more than 176 and less than or equal to 180. And those would be the two numbers that you would plug in this problem.